We are taking you behind the scenes of the National Institute for Data Science and Artificial Intelligence.
With unprecedented access to the scientists pushing boundaries and shaping our future, this show will take you to the cutting edge and beyond.
And whether you're an expert yourself or just science curious, this is the show for you.
Welcome to the Turing Podcast.
Hi everyone, welcome back to another episode of the Turing Podcast. I'm your host today, Bea, and I'm here with the lovely Anneca. Hi.
Hi Bea, how are you doing?
I'm doing okay. How are you doing?
Not too bad, not too bad. Thanks for having me again.
Yes, I love to have podcasts in person after so long recording, and I'm very happy to introduce our guest today because we worked extensively last year online, so I actually got to meet him in person. So please say hi or welcome to Dr. Robert Blackwell from CEFAS. Hi, Rob.
Hi, thanks very much for inviting me.
Oh, no, thank you so much for coming here and talking about your project. But before we talk about work and we talk shop, can you tell us a little bit about yourself?
Yeah, sure. So I'm Rob Blackwell. I'm a data scientist at CEFAS. CEFAS is the Centre for Environment, Fisheries and Aquaculture Science. So it's essentially the government's freshwater and marine science experts. So my background's in the computer software industry. I worked there for many years, and then about 6 years ago, I sold my business and then went and did a PhD, and now I'm a scientist embarking on my second career. So it's really exciting.
Oh my gosh, you sold your business to do a PhD. That's like, I commend you for that.
Definitely.
So thank you so much for being here. Now that we know a little bit more about you, do you want to tell us a little bit about CEFAS and what your work is at CEFAS?
Sure. So there's quite a wide variety of work that goes on at CEFAS. Everything from sort of aquatic monitoring through biodiversity and, of course, fisheries science that we're very well known for. And a real wide range of projects. So too many things to talk about, but some of the things that I'm working on is plankton science, and that's, of course, why we met to do some interesting work on detecting copepod and non-copepod from plankton imagery. But I'm also doing stuff around kind of machine learning to look at detecting litter in remotely piloted aircraft imagery. So we want to be able to automate the litter counts on the beaches, which is really exciting. And I also get involved in fisheries work as well, so salmon and trout, and sort of documenting the annual reports there. So real wide range of things.
Is this the first time you're working with marine biology and all of these different...
So I was fortunate enough when I did my PhD, although the PhD had a kind of strong computing focus, it was actually about krill. So I was very interested in using echo sounders down in the Southern Ocean. So we have lots of krill down there, and in fact, if you were to catch all of the krill in the world and actually kind of weigh it against all the biomass of humans, we'd probably have more krill than there is humans. So you could argue that krill are more successful species than humans. But we really don't know how much krill there is, and we send research vessels down every year to do krill surveys. So we want to try and automate as much of that. And so I got really interested in echo sounders and trying to process that echo sounder data. And so that was the thing that really got me interested in marine science, and that's how I kind of ended up working at CEFAS, really.
Great. I have a question actually. Why study plankton?
I study plankton. Plankton's pretty interesting. Do you know what plankton is? I mean, it's essentially the drifting stuff in the ocean. I have referred to it to my colleagues before as the kind of ocean snot, but they don't like me calling it that. But when you pull it out of the water, it tends to sort of go all gooey and horrible. But so we have zooplankton, the animals, and phytoplankton, the plant, and it's stuff that's kind of drifting around in the ocean. And generally, it doesn't have much ability to swim or to move itself, so it's at the kind of mercy of the currents. But it's really important because it's a major part of the food chain. So it's the copepod, particularly, a fish food. So if there's no food, that affects the fish. So we need to know about copepod for that. But increasingly, we're understanding it to be part of the carbon cycle as well. So it's the plankton is a big part of sequestering carbon dioxide into the ocean. So we need to know about that from environmental change. But perhaps the main thing really now is that we know that plankton are very sensitive to environmental change. So we're seeing them as a kind of environmental indicator, and we need to obviously study that. I mean, we've got a long history of studying plankton, actually going back just at least 100 years at CEFAS, people doing nets. But these days we want to study this patchiness. The plankton tend to arrive in sort of these random patches. So we want to know, are they random? Why are they sort of clumped together? What's the composition of those patches and so on? So yeah, I think important from a kind of documenting environmental change as much as anything.
Oh, that's really interesting because we don't think about that very much, right? When we think of the oceans, we think fish and big mammalians and stuff, but we forget that there's this little snot going around. I never actually pictured what it would look like out of the water, so now I have a very vivid.
So it's kind of a very diverse set of organisms, various kinds of biology. At various scales as well. So some so tiny that you can't see it unless you've got a microscope. Others are bigger lumps of things. And as you saw from the plankton imagery, a really wide variety of species as well.
That's really interesting. So you end up having a lot of data. Why do we collect so much data on plankton? Why is that
Yeah.
Yeah.
That's a good question. Well, I think it's back to this patchiness problem. So we've been net sampling for literally 100 years, and we put these ring nets in. But we know that nets are notoriously kind of biased sampling devices. You only get one net full. Do you know that net full is actually representative of the whole of that plankton patch that you're looking at? Probably not. It's a tiny sample. And there are millions and millions of these animals. So what we really want to do is sort of take a slice through these patches and to understand the whole composition. So in order to do that, we need very high resolution data, and that's why we're starting to invest in these other instruments. So we've been doing things like using echo sounders for many years. Echo sounder puts a sort of ping into the water and then measures the reflection from whatever is in the water column, both in terms of its intensity and the timing. So you can then draw an echogram. So we've learned quite a lot from that. We see diel vertical migration. So these, we know that some of the zooplankton come to the surface at night to feed, and then they go back down below the photic zone during the day because they don't want to be predated. So we see that, and you can see that effect kind of in echo sounder data. But if you actually want to study the individual animals, you've got to get into things like flow cytometers and plankton images as well, and that's really why the data's going up at a huge rate, because it's imagery now, and it's so when we went from an echo sounder might do something like 70 gig of data a day, but the new plankton imagery we've got is doing 2 terabytes a day, and so that starts to become interesting amounts of data.
It's definitely a data science problem at this point.
It is. I mean, it's not in the same league as the sort of Large Hadron Collider or something like that. I don't pretend that it's a big data problem like that, but it is a problem when you're bobbing around in the middle of the North Sea, and you're trying to store the data for a start, and you're trying to kind of process it, and then often you want to transmit that data, and in the middle of a force 9 gale, having a spinning disk. That's not necessarily a good idea from a storage point of view, and obviously we're now capturing too much stuff to store on portable hard drives. From a processing point of view, you can't really process this stuff on a laptop. A scientist taking his laptop on board the ship now, and that's problematic. And you get we're all used to having very ubiquitous bandwidth, but out in the sea, you've got a bit of satellite communications, and it's really expensive, so you can't send back images and so on. So yeah, it's a big problem, which is kind of why we came to you guys to help us fix it, really.
Because the truth is, on top of all of this, someone had to annotate this ginormous amount of data, and shout out to the PhD student doing it.
That's right, yeah, that's right. James did a great job. I mean, he had, I think the data set that we were playing with was something like 20,000 labelled images, and we had kind of we had sort of copepod and non-copepod, but we also had quite a lot of detail about taxonomy as well, and we're growing that set now. We need a bigger training set, but that was enough to prove the concept
An anecdote for our listeners is that I met the PhD student because of the work that Rob has alluded to, and he told us that he actually spent a month and a half just hand annotating millions of images.
Oh my gosh, wow.
But this is a big problem for CEFAS, right? Because a lot of what we're doing is monitoring, and we're pulling out fish, plankton, all kinds of things. And what are we doing? We want to know how big those fish are. We want to know the sex. We want to be able to sort them. We want to do taxonomic classification. All of those are really manually intensive tasks. They're all very skilled tasks because you need, competent taxonomists to do those things. But it's hugely time consuming. And so, that's the real promise, I think, of computer vision and deep learning, isn't it? The ability to automate that. And of course, when we have instruments like the new plankton imager, that's that can do something like 150 images a second. No human being's ever going to be able to keep up with that. So yeah, it's a real challenge.
Sounds very complex, and it sounds like there are quite a few challenges relating to the data storage, transmission and analysis in marine environments. We've kind of touched on the data study group and your participation in the data study group. What would you say kind of made it a success?
Well, it was definitely the people that made it a success. It was a tremendous experience. So I sort of cheated really, because I was part of the organisation that was the challenge owner, but I also made sure I worked on the challenge as well. So that was sort of cheating. So I got to work alongside a lot of early career researchers, people who were very enthusiastic, and it was a wide range of people. We had computer scientists, we had people who knew a lot about deep learning and computer vision, but we also had some plankton taxonomists and plankton ecologists on the team as well. So you got this real hothouse of ideas, people saying, wouldn't it be interesting if we looked at this, and people getting together and sort of forming ad hoc teams. And we had, because it was a remote session, we had people from all over the world as well. So we had almost this 24/7 working, didn't we, for a couple of weeks, and we had this quite a good plan, and people were off doing their own things. But we ended up with an algorithm that really worked. We ended up with an algorithm that was detecting copepod against the background of other things like detritus and non-copepod, and it's doing that with something like I think it was 97% accuracy on 95% F1 score, which is amazing, really, I think. But we wouldn't have been able to do that without having that sort of mix of people, really, people who understood the ecology and the biology, but people who also understood how to kind of marshal these machine learning algorithms and also all of the compute as well. So there's a great team at the Turing Institute that sort of put the cloud computing stuff together. So we had access to the latest kind of Linux virtual machines on Azure with GPUs. They helped us set up all of the NVIDIA bits and pieces and all the sort of compute stuff to be able to run those algorithms. And then, the Turing paid for us to be able to run those things for hours and hours at a time. So we ended up running some of these algorithms for sort of 20 or more hours. And everybody was kind of super excited about what the result was going to be. And people were getting up in the middle of the night. They were interrupting their sleep because they wanted to know what the outcome of the latest run was going to be. So, sorry, it was a long-winded answer, but it was a real hothouse of ideas, very, very, very intensive, really tiring. I think I sort of crashed and slept for the day afterwards. But we got so much out of it. We got a real algorithm that works, which we've gone on to actually use. But we also got a whole load of really good ideas and a document that kind of lists lots of stuff that will keep us and our researchers busy for probably many months to come, really. And some of those ideas are wacky, but that's what you want, isn't it? You want some new blood. You want some people to think in new directions. And that was a big part of it.
Definitely, thank you. Just for those who don't know, I should mention the Data Study Group is a quarterly event that takes place at the Alan Turing Institute. We have from 40 to 80, people come into the institute to work on set projects for a week-long period. I should probably say that again. I should have wrote that down. Sorry, Dan. We have multiple people come into the Turing Institute for approximately a week to work on various projects. If you'd like to know more, if you'd like to take part, please check it out on the website.
They had the DSG working remotely, as Rob said, and I was part of the team. I was part of the organising on this chairing part, and I can tell you that the results that we got were far beyond the expectations that we had set up before we started, because we knew that it would be a hit or miss, and we are very, very happy that it was a hit.
Yeah, but that's the nature of these things, isn't it? You've got to try them out. You don't know beforehand whether they're going to be successful or not. So you've got to invest some time and energy and some brain power. But you've got to bring experts together. If we at CEFAS had decided to have a hackathon or something to do that, we just wouldn't have had the broad range of expertise, particularly around kind of computer vision. So bringing the right people in to do that is key to that. Yeah, highly recommended. In fact, we're running another data study group this December, looking at another problem, which is looking for sea pens in underfloor or in seafloor video data. So we take lots of video material of the seafloor, and we're interested in the organisms and the what's going on there. And again, it's another counting problem. But actually, this is an even more challenging problem because we've got to locate the things within the video frames and then classify them as well. So really looking forward to that. And that one's going to be an in-person event, which is going to be new for me.
So you're going to be here in person?
That's the plan, yeah.
Yes, that's wonderful. You got like the pre-tour now. So when
Absolutely.
you come back in December, you're going to be like, look, I know where the coffee machine is.
That's right. So I've got to tell your podcast listeners about the coffee machine if they don't already know. So I came in this morning and you asked me whether I'd like a coffee, and I had to order it on an iPad. Where else do you have coffee machines that are controlled by iPads?
Only at the Turing. I do want to highlight something that you briefly mentioned, but I think it's such a good positive outcome, which is the fact that the algorithms that were developed at the DSG were actually deployed on a ship.
That's right.
Yeah, do you want to tell us a little bit about that?
Yeah, so once we'd finished with the algorithm, we obviously had the weights and all the information about that, and we could sort of reproduce that algorithm back at base with other data sets. So we did a lot more testing. But the instrument manufacturer themselves, they got really excited by this, and they ported the stuff to a different architecture. So these Intel compute sticks, which they all were already using with the instrument. So they were able to actually integrate the algorithm directly on the instrument, which means that we were able to try it out sort of live. And the kind of next phase of development for this is very much about thinking about real time. We want to have a sort of edge AI capability where we don't just collect these data and then go and process them later. We want to be counting the animals as we're going along, and that will give us a kind of real time series from the instrument itself, and hopefully start to redirect us and think about being able to go and chase these plankton patches and do kind of adaptive sampling. With too much in science, we kind of go and capture information, and then we bring it back to base, and then we kind of process it, and then we might publish it sort of 3 years later. But we want that to be much more instantaneous. We want much more real time and right time analysis, and so that's the next phase for that. So yeah, we really are using that algorithm and doing real things with it. Obviously, we're improving it as well. We're taking a kind of data-centric approach to try and get more training data, better training data, and refine that. But yeah, very exciting.
It's really amazing how this it was 2 weeks because it was online, but 2 weeks hackathon managed to have like such a big impact in just a few months. Yeah. Which is something I'm really happy about. I want to just highlight one of the problems that we had in the study, which in the hackathon, is that actually a lot of the data that you collect is to be dismissed, right? And you still had to dismiss it by hand. So that was our first goal with the DSG, which was to get an algorithm that would differentiate between what is information and what is detritus and things that we don't care about. But again, highlighting the participants and how amazing they did, they actually went beyond that, and you can actually separate between two types of interesting image, not just like detritus and non-detritus, but actually this is this type copypod and this is a non-copypod.
That's right, and that's really crucial for us because you obviously we get lots of stuff in the sea. There's bits of plastic, all kinds of particles, dead animals, and so you're seeing all things coming through, and you don't want to count those. And particularly, we want to differentiate copepod from non-copepod, because copepod is the stuff that's the fish food. So that's the key index that we want. And so being able to kind of exclude everything else and to do that very rapidly as well is crucial to it. Yeah.
Thank you. In terms of AI and its applications in fisheries science,
Yeah.
A lot of S's.
and I have a lisp as well, fisheries science, excuse me. Do you have much to add in terms of your thoughts with regards to this?
Well, just that we see so many different applications here, really. All of those kind of applications that we talked about, where people are, sizing animals, sorting animals, and so on. There's a big computer vision play in all of that. If we can provide automated systems to help scientists do all that counting, then that's got to be a big time saving, and it helps. It frees up scientists like James. He spent something like a month and a half or something. Well, wouldn't it be better if he was writing papers during that time rather than counting animals? He's a very smart guy. We need to focus his attention on the kind of key issues, really, and so by providing these tools, that's the way to do it. But I think, across the whole CEFAS business, there are all sorts of opportunities for AI and machine learning, predominantly around the sort of computer vision stuff, but I think many other applications as well, and particularly with regard to thinking about how we manage our assets going forward. We're increasingly interested in autonomous vehicles. So we have a wave glider, an autonomous vehicle that we can put out in the North Sea.
That sounds so cool.
Yeah.
It's like my colleagues would probably hate me for saying this, but it's like a super radio controlled boat, really.
No one is listening. But that sounds so cool. Sorry, it's just that this is such a different scope from what at least I'm used to hearing about. So when you talk about all of these things, I'm like, oh man, that sounds amazing.
Yeah, so we have to invest in that kind of technology going forward. It's very expensive to have ships out. It's essential that we have ships out, but we need to sort of augment the data that we collect as well. So we've got lots of smart boys out doing point measurements at various points around the UK. We've got acoustic monitoring systems out as well. So we have hydrophones out monitoring the background noise levels in the sea. So much data now that's sort of contributing to this ocean observing system, but we absolutely need more autonomous vehicles, and as they go out, there's not a human being on there to make decisions, so we have to use the technology to do that. We really want to go kind of chasing the phenomena that we're interested in studying as well. We don't want to be just drifting about and seeing what we get. Generally, we're studying things. People are interested in studying algal blooms. Well, you need Earth observation data to tell you where that algal bloom is going to be, and then you need to direct your equipment to go and find that and sample that as quickly as possible. And we're also seeing the research vessel as a kind of autonomous sensor platform as well. We have lots of scientists that go on to do very specific jobs, very specific kind of monitoring campaigns and so on. But why don't we just run all of the instruments all of the time? There's some devil in the detail there, obviously, but capture as much data as we can and have autonomous systems that processing that data, summarizing it. Wouldn't it be great if if you had the plankton imager running, even if there wasn't a plankton ecologist on the vessel, and the AI was just looking for that and saying, yeah, most of this is plankton that we know about. Oh, there's a really interesting animal. Let's keep that photograph. Let's count the interesting stuff. So I think there's a lot of we can do with kind of summarization of data, not exactly throwing away the boring stuff, recording it, but actually just kind of pulling out the highlights and alerting scientists maybe back at base to interesting phenomena that are being seen. So yeah, there's the sky's the limit really, and it's a major new direction. So we actually have a part of our CEFAS strategy that's come about in the last year now is around data and innovation, exactly to try and capitalize on some of these opportunities.
I do have a question, because you're mentioning gathering more data, but that actually means gathering more data. So that means that you're already collecting 2 terabytes a day.
Yeah.
So if you gather more, how can you how will you cope with the escalating of the even more data being gathered?
Well, cloud computing, cloud
Yeah.
storage is cheap these days, relatively speaking. So I think the first goal is to just get all of this stuff consolidated in the cloud. The problem is getting it from the ship to the cloud.
Yeah, that was my next question. Yes.
So the plan there, and we're not quite there yet, but the plan there is to buy some data boxes. So it's now possible with the cloud providers to get data boxes, which might be 20 terabytes or 100 terabytes at a go, plug them in, fill them with data, and then at the end of the cruise, actually ship that, courier that to the cloud provider, and then they will make that available as cloud storage. So that's the sort of initial plan, I think. There's some debate at the moment about whether we do need to keep all of these data. So at the moment, I'm pushing the agenda, which is let's keep everything for now because we want to use this as training data. But I think at some point further down the line, we will realise that some of this data is low value, and actually, if we've got reliable AI algorithms that can count stuff, what we're more interested in often is the counts rather than the individual photographs of the animals. So I think there's a mixture here. I think we'll use the AI to sort of prune the data, which will give us more manageable data. But at the moment, what we're trying to do is to not be afraid of the big data problem. I mean, we don't have the same big data problem as, say, the Met Office or the Large Hadron Collider. It's not in that scale. So let's go with it for a while. Let's see what we can capture, and let's see what kinds of new science it enables us to do, and then go from there. But for us, it's kind of a step change at the moment. We're used to, I've got some great colleagues, but we've been sort of data limited for a while. People have been throwing data away. They've been having to prune this stuff themselves, and I think it's time to say stop. Let's get on top of this whole data problem. Let's look at the end-to-end data journey and understand what we're trying to do with all of this. And so that's exciting for me coming in to help with CEFAS with that journey, I think.
That's a really good idea. I was going to say that's you don't know what information there is on the data that is being dismissed anyway. So if you have the capability of actually keeping a lot of it, might be useful.
Yeah. That's right. I mean, there are problems here. Obviously, it costs money to store stuff in the cloud, but there's cold storage. You can have offline storage, and so we need to experiment some more with that. I think at the moment, let's not throw anything away. Let's keep all options open and see what we can do. And hence the relationship with the Turing Institute. We want to bring more interesting problems to you to help solve, please.
That was actually going to be my next question, is how do you see the relationship with the Turing moving forward? And what are the plans for this relationship?
So I think we want more of a strategic partnership going forward. There are discussions about that at the moment. So you have a really interesting kind of environmental program that's going on, and we're very keen to be a part of that. So John Rowe, I think, is leading some of that initiative. I'm also meeting people like John Siddorn here, and he's got some great ideas about about cyber physical systems and thinking about how we pool all of this data, because at the moment a lot of these government agencies and science institutes, they do their own thing, they have their own data, but increasingly we need to be mixing instruments and looking at a bigger scale. So we want to be pooling all this data. We want to have compatibility of the data. So I think we'll at the moment we're focusing on kind of solving the CEFAS problems, but hopefully soon we'll be focusing on solving those bigger kind of marine science and fisheries problems across multiple organisations, multiple instruments, and at a much bigger scale. And that's what I'm particularly excited about.
Definitely. Another question for you. So in terms of the future, we have, you've mentioned digital twins. I think we had a chat actually about that off the podcast. But in terms of the future, how do you see digital twins being connected to CEFAS and your work?
So it's a really interesting space, I think. I mean, digital twin technology has been very powerful in kind of industry and the built environment. We all hear about digital twins of racing cars and digital twins of oil platforms, and you can kind of see how that works. It's a very nice idea to have a digital twin of the ocean, but the ocean is a much more dynamic kind of environment. It's changing minute to minute. It's very hard to pin down. We have some very good models, hydrodynamic models, and so on about how the ocean works, and we have lots of information about the animals within there. But it's going to be very difficult to have a kind of real time, up to date digital twin. So I think rather than use the word digital twin, we're starting to think about these kind of cyber physical systems. You know, what do we really want? What we want to be able to do is to capture data as part of a survey, have that brought back to some terrestrial kind of information system, so that colleagues who are not on board the vessel can look at the data and can be involved in the science. We want to be running the instruments more autonomously as part of that. But crucially, we want to be sort of informing the other way. We want adaptive sampling. We want to be looking at that data and having models say, actually, given what we've just seen on this mission, it would be a good idea if the ship now moved to a more targeted location, because that's what we want to study. So I think we're starting to look at the whole system sort of in terms of data collection right the way through to data storage, this sort of real time or right time actioning of the information that then actually affects the survey that's ongoing at the present time. And that's the thing that's new for us, and that I think is the win. And also, if those systems, those kind of cyber physical systems are, you know, kind of across organisations as well. I mean, we have one research vessel at CEFAS, but you know, the National Oceanography Centre has a couple, BAS has one. Why can't we pool those things? Why can't we make those things compatible? You know, if we're operating in similar areas, as we start to, you know, increase the fleet in terms of these autonomous vehicles, both, you know, sea gliders that go out, that go underwater, and the surface vehicle stuff as well. You want to sort of pull all of that together in one space and have all of that informing the sampling that you're doing. So I think that's the prize really, and whether you call it digital twin or whether you call it a cyber physical system, that's really what we want to do. It's all about directing the sampling, I think, and doing that in real time.
Controversial question that I thought about while I was hearing you talk, because we've been talking about how great data science is and how it can help, and AI can help all of this. But my question is, this is a field that still has a lot of people doing things by hand. Do you see some apprehension from people that are used to doing things a certain way and might see that their jobs have, I don't want to say, would have a certain level of redundancy, and that could be seen as a threat? So how do you see data science and AI influencing these people's work?
So it's a really good question, I think. And yeah, if you've ever tried to publish a paper that talks about automated processing of echo sounder data, it's really, really hard. I've got a paper where we're doing that automated processing, just cannot get it published because everybody's worried about the black box. Everybody's worried about, you know, the fact that, okay, well, I've trained that on data from the Southern Ocean, but would it work in the Mediterranean, and so on. And those are all really valid questions. We've got to have humans in the loop going forward. It's a given. We can't just let these AI algorithms run and hope that they won't run for years. They've got to be continually trained. But I think what this is about is changing what the people are doing. It's not about replacing them at all. You know, kind of visual observation is still a massive part of doing science. But what we want the scientists to observe is the important things, not the mundane things. And so the AI has kind of got to be complementary. It's got to be an add-on. It's got to be a sort of decision support system for scientists, not a replacement for scientists.
That is great, and I think it applies to a lot of fields that have now an increase in automated systems, because the idea is to enhance the science, right?
Yeah. And
enhance the work of the scientist, not replace it. I just wanted to ask the question because I was thinking about it, how we're talking about autonomous vehicles, but it does imply that a lot less people would go on those vehicles.
Exactly, but I mean, and that leads to another kind of question about ships, about research vessels. I mean, running research vessels is a very expensive operation. So, you know, lots of people have been saying, well, can't we replace research vessels with autonomous vehicles? And the short answer to that is no. You know, you can't do the same things with autonomous vehicles that you can do with research vessels. They're different ways of sampling. it's more difficult often to direct an autonomous vehicle to the right place immediately. A ship can get there very quickly. So I don't see research vessels going away. I don't see scientists working on research vessels going away. This is all about augmenting that science and thinking about it in a different way, and sort of using autonomous vehicles for this sort of mass coverage and high resolution at points, but continuing to do the observation and the critical work that the research vessels do. And the other key thing that we must remember is that research vessels are about servicing smart buoys. They're about servicing these autonomous vehicles as well. It's kind of like the mothership for all of this, and so they're not going to go away anytime soon either.
That's really good. Thank you so much for answering that. I know it was a bit off script, but you were just talking about it, and I just had like this question.
That's good.
So thank you for answering that. Just aside, if you had said you don't know exactly, I would be like, damn. Ignore that last bit, please. But I'm glad you had an answer. So now on a question about you, because we've talked about the work and the future and how the DSG impacted the work at CEFAS, but how did it impact your work? What's your personal experience with being part of the organization, but also being a participant of the DSG and then continuing the work beyond the DSG and actually having to take everything hands-on yourself without, hand-holding?
It's a really good question. So I was very much in at the deep end with the data study group. So I'd only been in post something like 6 weeks when I did the study group. So it was all new for me. So I was brought on in a team called Data Science and Statistics. So most of my colleagues are really smart statisticians, and that's not really my skill set. I'm enjoying working with them. I'm learning lots of statistics, but my background is very much in kind of compute. So that was kind of where I wanted to add the value. I'd done some data science and machine learning, but it's such a fast-moving kind of area that the stuff I'd done felt quite out of date, really, even in the space of a PhD. So for me, it was a big sort of shot in the arm, I think, and I think also for the organisation, because we were able to do so much in such a short space of time. We tried out lots of different algorithms, and so I felt like I went back to the workplace with lots of good ideas and lots of things to try out. And so the first thing I did was just kind of built the same compute environment that we'd been using for the data study group, just kind of replicated everything and just got the data study group code all working on our own infrastructure, proved that out, working with some of my IT colleagues who were also really excited about the DSG as well. And so we kind of built that capability. And then having got that capability and gaining confidence in it, we were then to start to lots of other people at CEFAS said, well, if you can solve that problem, what about this problem? So it's
can you
really
fix the
kind
printer as well?
Yeah, no, not quite like that, but computer vision related problem. So that's led to much more interest, really, and we've been running these machine learning deep dives to try and kind of downstream the knowledge and share the knowledge around. And there are other people in CEFAS working on machine learning algorithms as well. So it's about bringing people together to kind of share that information. But the thing it's enabled me to do is to have more of a focus on kind of data intensive applications and machine learning stuff. Whereas I'd been open to all kinds of projects, including statistics. I'm still doing some fisheries assessment type work, and that's interesting too. I think increasingly I'll be focusing on this data intensive stuff and computer vision and machine learning. And certainly, if as I hope we get closer to the Alan Turing Institute and have more of a partnership approach on this, then I'm hopeful that my career trajectory will be along those lines. And I find that tremendously exciting.
It was really exciting to see this relationship between the Turing and CEFAS growing as well, because I think your work is super important and super relevant for the environmental program that we have.
I think there's a coming together of things here, isn't there? Because we're really good at data collection. We've got the instruments, we've got the kit, we've got the research vessel. We can go and get these interesting data sets. We've also got the questions as well. And so, you guys have got the knowledge and the experience and the latest kind of approaches for data science and machine learning. So you plug those things together, I think that's when you get really interesting results.
Yeah, I agree.
Definitely. And it's really positive as well that CEFAS are sharing that information as well with the colleagues. It's really good to hear.
Yeah, I mean, I think that's one of the challenges that we have. We need to broaden out this. We need to build a bigger team that's working in these areas. But we need sort of kind of more, I was going to say data literacy, more awareness of what can be done. It's the sort of, it's telling colleagues about the art of the possible, really. And because we have some really smart people, and if they see these projects that we're doing and that the Turing are doing, and try and relate that back to their own work, well, as those conversations are happening, well, even more and more applications are kind of going to come out of the woodwork, I think.
No, that definitely. That I think it's a very valid point you said. You have the data and you have the questions, and if we can provide tools to help you answer those questions, that's really good.
Yeah.
My next question is, what are your expectations for the next DSG? Because we went into the first one with moderate expectations, but it went brilliantly. So.
Well, so the next DSG is all about counting CPANs in this seafloor video data, and we think that's a hard problem. We've had some smart people have a go at that, and they've done a pretty good job actually, and certainly shown it to be a very promising area. But what we really want to do now is to try some different algorithms out and to have a broader range of expertise on it. And I think if we can get that sort of hothouse approach going again, lots of ideas, lots of brainstorming, we'll be able to try lots of things out and see what works and what doesn't work. And I think that's another journey for us, really. We have lots of video material, so this is one of the early kind of forays into dealing with video material, I think.
Just a quick question as well for the lay people out there. What is a CPAN?
That's a good question. So I should say at this point that I'm not a biologist or an ecologist, but I've seen pictures of them, and they look like feathers, and they stick up from the sea floor, and they're marine organisms, and they're also thought to be interesting indicators of environmental change as well. So they're sort of pretty things. If you go and Google it, you get lovely, pretty pictures of these things that look like these organisms that look like feathers sticking up from the seafloor.
I'll definitely check that out. Thanks.
There's going to be a Google spike on on searches for CPAN after this episode comes out.
Yeah.
Thank you for asking the question. I was like, am I the only one that doesn't know what a CPAN is? Cool. And I was also going to say that there's nothing like having a week of sleep deprived people trying to solve a problem.
Absolutely, that's right. I think it's the coming together of those people, isn't it? Really, and I'm looking forward this time to it being in person. I mean, it was great doing it remotely, and COVID was different times. But I think here, and certainly having seen your offices today and this kind of co-working spaces that we've got as well, I think it's going to be great.
No, I'm looking forward. I won't participate this year. I won't be involved. But I really look forward to see what is going to come out of it. And sure. I'm so happy you're going to be here in person and, just enjoy the coffee machine. So what is there anything else that you want to touch on? Is there anything in the future that you want to tell us about?
Blab is just going to make some observations really about how fortunate I feel to be involved with you guys. I'm quite an old guy, as probably your podcast listeners won't have realised. So this is a sort of second career for me. I had a long career in the computer industry before trying to become a scientist. And I actually remember an organisation called the Turing Institute back in the early 90s. That not a lot of people will remember that, but there was an organisation called the Turing Institute in Glasgow that was studying AI, and I was very interested in that at the time. We were doing things like symbolic computation. We were doing rules-based systems, and I was doing a lot of kind of so-called expert systems in the telecom space. So it's kind of like full circle for me to come back to see the new Alan Turing Institute here in London. And of course, the whole field of AI has changed so much now. The things that are doing now we just couldn't have even contemplated back then. So to now be working in AI again, and now it being about convolutional neural networks, computer vision, deep learning, and so on. it's just a fantastic experience for me. So I sort of I had a big grin on my face when I walked into the Alan Turing Institute this morning. So thank you.
I can confirm that. I was right next to it, and there might be a sneaky selfie that you took.
I always like to ask this question. How can people get involved? You know, are people able to go on your website? Can people view some of these images, or is it open to the public? How can they?
Sure. So the plankton data study group, everything that came out of that is open. There's a report that's up on the Alan Turing Institute website, very comprehensive report, and all of the code and all kind of information associated with that is in a GitHub repository as well. I'm not sure about the data, whether that's been published. I think it is, isn't it? Is that on Zenodo?
Yeah,
but
and
if
there's
anybody
a
wants
notebook
that
as
data,
well.
yeah, so that's all around. We have SciVision as well. So the model that got produced got integrated into SciVision. So lots of ways that people can kind of play with those data as well. Or just reach out to us.
Fantastic.
And how can people reach out to you in particular? Do you have like social media?
I do, but I'm just trying to remember what my. I am at Rob Blackwell, I think.
Okay,
on
wonderful.
most of the social media platforms.
So people can just Google your name and maybe CEFAS, and in case there's.
Yeah, or if you're old school, you'd go to a website, robblackwell.com.
Oh, wonderful! That's perfect.
Yeah, even better.
Yes. Thank you so much, Rob, for being a guest here, for coming to the Turing, coming all the way here and having a chat with us. It was lovely. It was lovely to have this conversation.
Definitely. Thank you so much.
Yes.
Thank you. I mean, it's just been a great experience, and I'm really hopeful that we'll do some more good stuff together in the future.
Oh, I'm sure we will. Yeah, thank you. Thanks for listening to this week's episode. The Turing podcast is produced by Dan Whitfield for the Alan Turing Institute. The show is hosted by me, Bea Costa-Gomez, Ed Kalstry, Joe Dungate, Christina Last, and Anneca York. Music for this podcast is produced by Jam and Sun. You can listen and follow via the link in the description or by searching Jam and Sun on Instagram.